Alrighty, good evening, everybody. I wanted to spend a little time talking to you guys about how to use Excel and kind of going through some of the basic functions of it so that you can view this if you need to make graphs and tables at home. So I'm going to be using the data from our determining the density of an unknown solid lab. So that's the data that I'm going to be using when I do this, just so you know. So the first thing that you need to know about Excel is it does a lot of great things. It makes tables really easily. It does math for you if you know how to use it. And it makes beautiful graphs. Some of the basic things that you should know: these are columns, these are rows, and you can adjust the height of your column or row doing various things. If you want to change the size or the width of your column, you can take the pointer and run it up and down just like that. You can also, if you type in here, the fact that my typing has gone outside of the box, so that is larger than one cell, and I can adjust this automatically without having to slide it by double clicking in between columns A and B, and it makes A automatically large enough to accommodate the text that I put in there. Okay, so starting with a clean, fresh slate, let's say that I went and took some data for the density of a solid, and I want to input this data into Excel so that I can make it nice and neat for a lab report. First thing that I want to do is create some sort of title or label for my table so that I know what it's describing. And so for me, I went ahead and I did the density of the green transparent solid. So I would write green transparent solid. And you guys are going to see how bad my typing is as we go through this because I'm typing live time here. So then I need to make up the table and show what each table with each column and row needs to be labeled appropriately so that I, as the teacher, know what you're describing. And it should be very descriptive and easy to see what trial you're talking about, what are you massing, what exactly is going on. And so the first thing I'm going to describe is what object I'm going to be getting data about. So I'm going to put in solid size, because that's the best way with our unknown solid. There was 4 of them, and the best way to describe them is that one was small and one was big. And so we're going to talk about solid size. I then also took data using both an electronic balance and a triple beam balance. So I'm going to write electronic balance mass, and here I'm going to put my units, grams. And you want your units to be in the label of the column, not with the numbers, so that you can use the numbers to do calculations. If you put letters or units attached to a number, say if I had 1.3 and I put grams here, I would no longer be able to use that cell or those numbers in any calculations that Excel can automatically do for me. So to bypass that issue, we put the units up at the top of the column, saying that all the numbers in this column below this title are measured in grams, so that then we can just put simple numbers in there and we know that those would be grams. So I have my electronic balance mass, then I have a triple beam balance mass, also in grams, and I'm resizing these columns as I go. We also took the initial volume when we did our water displacement, and that was measured in milliliters. And then we had our final volume, and that was also measured in milliliters. Something that I'm going to want to show and use in my graph later in determining density is I need to have a volume difference. So a total volume displaced. And this is where I'm going to put final volume minus initial volume. So let's start filling in this table. I had a small piece, a medium piece, a large piece, and an extra large piece. Now here, I'm going to go ahead and size that again. So, electronic balance mass. I'm going to fill this in with some data that I recorded yesterday. So, for the small one, it was 5.61 grams. For the large one on the electronic balance, I got 9.17 grams. For the medium one, it was 12.56 grams. And for the extra large one, it was 15.91 grams. When I measured it with the triple beam balance, I got 5.41 grams, 8.99 grams, 12.42 grams, and 15.75 grams. When I was doing my water displacement, I had an initial volume of 25.8, 28.3, 52.3, and 52.9. And then I had a final volume of 30.0, one of 36.1, 63.0, and 66.0. Now you'll notice as I typed in 30.0, 63.0, and 66.0, Excel automatically got rid of that decimal and the first zero. Now that is because it doesn't think that it's a significant or important figure to include. However, we know that we were taking important data, and that if we want to show our precision, which as a teacher I need you guys to show how precise you were being with your instruments, you're going to have to adjust these cells to compensate for that. So I'm going to highlight all of these cells because I know that anytime, I'm actually going to highlight all of my volume cells, because I know that anytime I was taking a volume in this experiment, I was recording my volume to 1/10 of a milliliter precision. So I had the reading to the 10th decimal place. So I'm going to adjust these cells so that they always read out to the 10th place. So I highlight these with my mouse. I'm going to right click on them and go down my drop menu and click Format Cells. Once I'm in here, I get a pop-up window about formatting cells, and under this number tab I have a category that says number, and it gives me the opportunity to adjust decimal places. And what I want to do is have one decimal place associated with this. I want to be able to show that I was recording to the 10th place, or the first decimal place. So I lower that to 1 and I press OK, and automatically my 30.0, my 36.0, and my 66.0 comes back. I can do the same over here, even though none of those had zeros in them, just to ensure that those values are correct, and say Format Cell, Number, and then with the masses, they read out to the 100th place, so I did need 2 decimal places, so I can click OK, and then if any of those values had been zeros, those would be filled in now. Now here, is going to be my total volume displaced, and so ahead of time, I'm going to go ahead and highlight these cells and indicate that I need these results to have the same number of significant figures as what I'm going to be obtaining them from, my final and initial volume. And so I need them to be accurate to the 10th place, right? All of these values are to the 10th place. So I need them to be accurate to 1 decimal place. All right, now this is the great part about Excel, and it's what makes it different from Logger Pro, is that I can have it do the math for me. Now, if I'm going to have Excel do the math for me, I need to show what the math is that is being done. And so above the column, you're going to put what math is going on in here. And so I will put final volume minus initial volume. Okay? To show that that's what I'm doing here, is I'm taking the final volume and subtracting the initial volume from it. So if a teacher were to come along and say what was going on here, I would be able to show them. And then just for formatting purposes, I wanted to put that in the center so that it looks a little bit nicer. So I centered it. Okay, so to get Excel to do the math, you need to let it know that it's going to be doing a function. And in order to let it know that it's doing a function or a mathematical equation, you have to type in an an equals sign. So I'm going to type in equals, and then you just have to tell it what to do. And I want it to take the final volume and subtract the initial volume. And so what I did there was I merely clicked, and I did just a left click, a normal click of one cell, then I typed subtract, and then I clicked the cell that I wanted to subtract. And now I'm just going to press enter. And as you can see, it gives me 4.2 milliliters, which is exactly what I wanted. That's the difference between 30 milliliters and 25.8 milliliters. Now I could continue to type that into each one of these cells. The other great part about Excel is that it is supposed to be there to make your life easier, and so we can, if we take this cursor and drag it down to the bottom right hand side of that cell, it becomes a little black cross. If I click on this corner and drag it down, it's going to apply this function to all of the cells below it, and it's going to do the math for me automatically. Now to show you that this is the correct math, I can double click this cell and it's going to highlight and tell me I'm taking this cell and subtracting this cell, which is exactly what I wanted it to do. So this is awesome. This is the data that I wanted. It's already there for me. So I'm going to make it look a little bit nicer. One of the things I'm going to do is I'm going to highlight all my cells and right click on Format Cells. Now I'm going to add borders to it so that I can easily define which rows are which rows and which columns are which columns. I'm going to click outline, outside and inside, and OK. And there you see I've got a nice table that shows me what I want. And just to differentiate the titles, I'm going to highlight all of those and bold them. And that made my column widths a little small because bolding takes up more room, so I'm going to go back and adjust. Okay, so now the whole point of this lab was to get the density, and getting the density I do that through graphing. So now I need to create a graph. So I'm going to go up here to these different tabs. These are all my different types of tabs in here, and I'm on the Home tab right now, which kind of gives you your basic editing tools. But I'm going to go into Insert, and this pops up a whole nother variety of tools available. And I need to insert a graph or a chart. Now, for density, I wanted to have points, right? We discussed that in order to determine the density using a graph, we're going to graph the volume versus the mass, and we need a line or the slope of a line to determine what the density is, because the density is the change in mass over the change in volume, or the change in y over the change in x, the slope of the line. And so in order to get that accurately, we're going to have to do a scatter plot of our masses against our volumes, and then do a trend line. So I'm going to need a scatter plot, but I don't want my scatter plot to have a smooth line or a jagged line, straight lines. I want it to just have markers or data points. This is the most common graph that we're going to do as a class, is data point graphs, or a scatter with markers only. So I click on that and I get this empty chart, and it has nothing for me. And so I need to start filling in the data. So if I click on the chart, I can either click select data up here, right here, or I can right click on my chart area and press select data from down here. But this is just me saying, all right, I have this blank chart, now I'm telling Excel where I want it to get the data from to make the chart out of. And so when I press that, I get this pop-up window, and I'm going to move that out of the way so I can easily see what I need. And you have the chart data range, which is just something that I don't care about, so you don't need to care about either. What you care about is the legend entries series, or this is where we say, these are the graphs that I want to make. And so we're going to add a graph in, so we're going to press the add button. Next pops up a new window, and it tells me what do you want your series name to be. And so this is where I describe which graph I'm doing. And since I'm graphing two graphs in the same, or two lines in the same graph, I need to distinguish them. So I need to have a name for it. So I'm going to describe this one as the electronic balance, because this is going to be the line that uses the electronic balance mass against the volume. So I fill that in. Then I look at my series X values, and this says, what do you want to plot on your X axis? And my X axis is supposed to be my volume. So in order to select it, I click this button right here. It's got a red arrow, and it looks like it's pointing to a spreadsheet that you're highlighting. So I click on that, and that gets smaller, and I say, okay, I want to plot volume, but I don't want to plot initial volume or final volume. I want to plot the actual volume that was displaced, or the volume of my solid. And so I just highlight with my mouse the 4 volumes that we got, and I release that, and I come back over here and I click to expand this, and it gets me back to my edit series. And then I need to input the Y values, or my Y axis values, and I click on the red arrow, and this is where I need to put my electronic balance masses. So I'm going to click over here and highlight those 4. And as you can see, I've got a nice little graph going on over here. So I say, okay, that looks excellent, but I'm not done yet. I've done my electronic balance. Now I need to do my triple beam balance. So I'm going to add another series. This one is going to be called the triple beam balance. My X values again are going to be the same. It's going to be the same volume that we used before, or the total volume displaced by my solid. But my Y values are going to change this time. This time they're going to be the masses found using the triple beam balance. So I'm going to click on my red arrow and highlight my triple beam balance masses. And I'm going to click OK. And again, we can see that I've made a nice little graph. And I'm going to say, OK, I'm done. Now, this is kind of hard to see because it's so small. And so one of the best things to do when you make a chart is to put it in its own sheet. Right down here in the bottom left side of the screen, we have sheets. So these are different pages within the Excel spreadsheet. And so we're going to create a new one specifically for the chart so we can see the chart in full screen. And so the way that we're going to do this is we're going to right click on our chart, and we're going to say Move Chart. And then we're going to apply our chart not to a new object in sheet 1, but we're going to apply it to a new sheet on its own. Okay? And this is where I could rename it. And so I'm going to say green, transparent, solid, unknown. Okay? And I'm going to say OK. And it automatically opens up. So if you look down here, you'll see that our sheet 1 is still there, but now we have this new sheet, and it's this chart here. And it opens it up, and it's nice and beautiful and easier to see. So now what we're going to do is we're going to plot trend lines for this data. And so in order to do that, all you have to do is click on one series of data. And so I'm going to click on this data point, and you can see it highlights all 4 of my data points of the same one, and this one is the triple beam balance. So I've clicked on it, and you can see up here it says series triple beam balance, so I know it's my triple beam balance data points. I'm now going to right click on them and say, from the drop down menu, pick Add Trend Line. Now I get a new pop-up window, and we want it to be a linear trend line. That is true. We also want to display the equation on the chart, because the whole point of this trend line is to determine the slope of the trend line so that we can determine the density. And if I click Display Equation on Chart, it'll actually show me the slope of my line. And then I want to see how good or how accurate and precise my error was, my experiment was, my data. So I'm going to say display R² value on the chart, but we'll talk about that later. I'm then going to, since we have 2 graphs and they're so close together, I want to be able to differentiate between my 2 trend lines. So I'm going to change my line color. And I want it to be a solid line. And this was the triple beam balance, which was the red squares. So I want the color of my line to now be red. Now, as you can see, that red line is really tiny. So I'm also going to change the line style, and I'm going to increase the weight or the thickness of the line. I'm going to increase it to 1.25 points. And then I'm going to say close. Now at this point, this trend line right here has this information, and I'm going to put it below down here so that I can associate it with it. And just to be doubly careful that I know that this information is associated with this trend line, I'm going to go home and I'm going to change my font. So I'm clicking on the Home tab, and I'm changing my font, the A with the red line under it. I'm going to change its color to pink. Okay? And so there it is. Now something else that you might want to do is insert an arrow to actually point from that equation to the trend line, because chances are we're going to be printing on black and white printers, not colored printers, and so we need to be able to distinguish, because blue and pink aren't going to look that different on the black and white printer. So I'm going to pick an arrow from my insert shapes. I'm going to pick this arrow, and I'm going to draw an arrow from here up to my trend line, and then I'm going to change the shape outline color to pink, and I'm going to edit it, format the object, and I'm going to increase its weight to 1.25 as well. Alright, now that's kind of extra fluffy stuff. You don't necessarily have to do that. If you wanted to draw that in pencil, if that was easier for you once you've printed out the information, that is perfectly acceptable. But I want to show you all the neat things that you can do in Excel. Alright, so we've made the trend line for our triple beam balance. Now we need to do our electronic balance, so those blue points. And those blue points are harder for me to see because they're kind of covered by the triple beam balance. So I'm going to collect one, and look, as I hover over the points, you can see what the series is. If you look at the series, I get like a little tag associated with my arrow, and it says series triple beam balance, and then it tells me the point, the actual point. When I come up here, I can hover, and I see that I'm on series electronic balance. And so I'm going to click that, and that way I know that I am on series electronic balance right up here. And so I know that I've got the right series. And so then I'm going to right click on that and do the same thing that I did for the triple beam balance. I'm going to add a trend line. My trend line again, I'm happy with a linear trend line. I want to display the equation and the r squared on the chart. And I'm going to change the color of my line to blue this time, because with the blue data points. And I'm going to increase its point weight up to 1.25% as well, or 1.2 points again as well. And I'm going to press close. And again, it gave me my nice little graph. And so I'm going to change the font there to blue so that I know that it's associated with it. And I'm going to go ahead and insert that arrow again, this time from here to this trend line. And I'm going to format that object and put the weight up to 1.25. Alrighty, so I can see nice equations, nice slopes. This graph is beautiful. I really like it. It looks neat. It looks tidy. Everything is pretty good except for I'm missing something. I'm missing two things actually. I'm missing a title, and I'm missing axes labels with units. So in order to do that, we're going to go up to here to the center where this green Chart Tools tab is, and we're going to it's highlighting the design, layout, and format, and it's specifically of the chart. And so we're going to go to layout, and we're going to see chart title right over here, and we're going to input a chart title, and you can do centered overlay title or an above chart title. It doesn't matter. So I'm going to click above chart title, and your chart title needs to be descriptive. I don't just want the x-axis versus the y-axis. That's not good enough. It needs to be a title that describes what the experiment was about. And so I'm going to write determining the density of an unknown solid. Okay, and I could see it typing up here as I went. All right, now as you can see, something because we input this title, everything in here kind of shifted around, and so I need to adjust my objects accordingly so that they're still pointing at the right thing. Okay. Now I need to put in axes labels. So I'm going to go back to, I need to click on the chart again, layout and axes titles. I'm going to go the horizontal title first. And so this one is going to be my volume, and then I describe it in milliliters. So I put milliliters in parentheses there. And then I'm going to give my axes title primary vertical axis, and I'm going to go with the rotated title, and it is a mass in grams. Okay. All right, now let's make sure that everything has shifted accordingly and that nothing, and the things that are pointing where they need to point, everything looks great. I'm going to shift this up just a little bit. All right, and that is a beautiful graph. That graph is great. It's got a descriptive title, it's got axes labels with units, it's got a series legend so that I know what everything is, and then it's got a trend line with the associated equation on it, and it's telling me which equation is associated with which line. It's a great graph. So the point of this was to determine the density, and I said that the density of that unknown solid would be equal to the equation of the slope of the line, of the trend line. So if I look here, I can see that for the electronic balance, my density is my slope, which is the mx part. It's the m of the mx part of your trend line. So a straight line graph has a formula of y is equal to mx plus b. The slope is the m part of it. So here is my m, there's my x. So the slope of my electronic balance was, and I'm going to write this on a little piece of paper to the side so that I can remember it when I return to my other sheet, was 1.1504, and that's the electronic. And my triple beam balance, the slope is 1.156. All right, so I'm going to click back into my sheet and get back into my information here. And I'm going to do another table for determining the density and percent error of an unknown solid. Green, transparent. Okay. Up here on this original title, I'm going to add something to it. And you'll be able to add this to yours tomorrow. I'm going to look up the known density of my unknown solid, okay? And I have a little booklet here that tells me what the density of all those solids was, and it says that a green transparent solid has a density of 1.17 grams per milliliter. So that is a data piece of information that I'm going to use down here in determining my percent error. So again, I'm going to put what solid I have. What is my solid? Next, I'm going to describe the type of balance that I'm using in order to determine the density, because that was the difference between those two lines, was the way that we determined the mass. So I'm going to say balance type, and then I'm going to say the actual, this is the actual density, or also known as the experimental. And then this is going to be my theoretical density, also known as the known density. And then this is going to be my percent error. And then over here I'm going to write percent error with correct sig figs. Alright, so my solid was green, transparent. Okay, so I'm going to increase that a little bit. Now, I had two different balance types. I had electronic balance, and I had a triple beam balance. Now, from the slopes of my lines, I found that the electronic balance had a slope of 1.1504, so 1.1504 grams per milliliter, and my triple beam balance had a slope of 1.156, so 1.156 grams per milliliter. Now the theoretical or known density was given as 1.17 grams per milliliter, and so that's the same for both of these because it's the same solid. So now we need to determine the percent error. And so up here, I need to tell a reader how am I determining this, because I'm going to make Excel do math again. So my percent error is my actual minus theoretical divided by theoretical timesing it by 100. Okay, so that's how I'm determining my percent error. So again, I'm going to make Excel do math, so I have to type in equals, and then I'm going to put parentheses because I want to divide this whole subtraction. So I'm going to put parentheses, actual value minus my theoretical value, and I want that value, that subtraction, to be divided by the theoretical value, and then I want to times it by 100. Okay, and it gives me a percent error of negative 1.6727521365. Okay. Again, I'm going to use my drag function to drag that function down, and it determines my percent error for this as well. Again, I see that it was the actual minus my theoretical divided by my theoretical times 100. It's the exact function that I wanted it to do. And so I have 2% errors there. Now, the question is, what are the correct sig figs for this? And remember, we have to go with what is the data that we actually used. What is the data that we collected, and what were the significant figures associated with that, or the limit of precision on the equipment that we used. And so if I look up here, I was able to get 3 sig figs minimum with the electronic balance, and 4 sig figs here, and then initial volume I was only ever able to get at most 3 sig figs. There was nothing fewer than 3 sig figs. So I'm going to be limited to 3 significant figures in my percent error. So in here I'm going to take my value here and I'm going to type it in with the correct number of sig figs. So I have negative 1.6, and 7 is going to be my third sig fig, so I have to look to my 4th digit, and it's a 5, so it's going to be negative 1.68. And then the one below it is negative 1. And it'll be 1, and then my 9 is my third sig fig, but the next number is a 6, so I have to round up, so it actually becomes negative 1.20. Okay. So I'm going to make this a nice pretty graph by putting borders around it. Remember, I highlight, then right click, select format cells, and outline an interior border. And then I'm going to bold my titles so that I know that those are titles. I'm going to adjust the height, the width a little bit again to accommodate for some bolding expansion. And that is pretty much it for what you had to do. I would then take this and either print it out from here and attach that to my lab, or if I was wanting to type up the entire lab, you could copy and paste this into a Word document. The only problem with copying and pasting this into a Word document is concerned with your column widths. This may be wider than your traditional 8.5 by 11 in the portrait size, so you'd have to adjust down from that. But I can talk to you guys about that at another time. Otherwise, I hope that this has been a helpful demonstration of how you can use Excel to do a lot of work for you and create beautiful graphs and give you information and percent errors and everything like that. Oh, hold on, did you guys see a mistake? My negative 1.20, the value is removed. I don't have a sig fig, so I need to correct that by right-clicking on the cell, saying Format Cell, going over to Number again, and saying 2 decimal places, okay, and getting, again, that 0. Because even though it was your intent to use the correct sig figs, Excel took that away from you, so you need to make sure that you use the correct sig figs, that Excel doesn't correct that for you. Alright, so I hope you guys that this was helpful for you. I will try in the future, if we use Excel for any other purposes and use other things in it, I will try and do some more notes like this, but for now, this will have to do. I hope you guys enjoy this and that it helps a lot, and have a great night.